All right, so welcome everyone today uh, to join sort of the first monthly development meeting on offline reinforcement learning. So in this meeting, we'll be mainly talking about maybe a couple of the papers we've read on offline reinforcement learning, and hopefully we can decide on which reinforcement learning algorithms to work on for sort of the next month. So maybe to get started, it will be, has anyone find any particular paper interesting, anything they want to share?
Not paper-wise, but I've been trying to install the D4RL library because that has some data sets already available and start integrating that. So that's here. I'll paste the link.
Yeah, I thought the D4RL paper is quite interesting. They provide a lot of offline reinforcement learning data set, right?
Yeah, I think they submitted to iClear and they got a really negative review by one reviewer just because they used MuJoCo.
Yeah, apparently that has caused quite a bit of a splash in the community. Yeah, I don't know. I feel like using MuJoCo is, making it difficult for some people, but at the same time, the authors have obviously put in a lot of work, and they shouldn't be just given a rating that is extremely low.
Yeah, I agree with that. I personally have had struggles getting MuJoCo licenses and so on, but
Yeah.
it's not the fault of the writers that's become the standard benchmark.
Yeah, especially for me personally, if I want to run large scale experiments with MuJoCo, it's very difficult because you have to have a license, like a actual institution license, to be able to use Docker to run. Otherwise, you can only run it on your local computer.
Right, one computer machine.
Yeah. Okay. Maybe I can sort of talk about some of the papers that I've read, or just some maybe thoughts on it to get the discussion started. Where is okay. Let me see. Is everyone able to see my screen?
Yes.
Okay. So I've read a couple papers. The first one is the one that Ali has mentioned, an optimistic perspective of offline reinforcement learning, and also listened to the YouTube videos by Sergey Levine, sort of introducing the offline reinforcement learning. It's just a general topic, but as well as their newest development. So I already posted the link in the Slack channel in case you want to check it out. I think it was a very well done video, so feel free to check it out. Overall, right. So the YouTube video is actually talking about another paper called conservative Q learning. And that's something that I've been curious about. But also, so Ali, you're obviously the expert in the field. Do you know any difference between this paper or so I think CQL is maybe a little newer, but what's your opinions on both of them?
Yeah, I'm not the expert, but I'll try my best. Sorry, are you comparing CQL with the optimistic perspective paper? Okay, yeah, I think the optimistic perspective paper, they focused on just reusing C51 and the quantile regression model, and then making this ensemble network they call REM, and then seeing how that performs on Atari environments. So they didn't make any changes to the underlying algorithms. They just applied them and see if a good enough algorithm works well on these rich data sets.
Mm-hmm.
Whereas CQL, I have to read the paper again, but I think it's like a continuation of the Bear paper, BEAR, where they
Okay.
actually make that modification to the update rule. That they don't make update that straight too far from the previously observed data. That's gonna be hard to search, but yeah, there you go. You got it.
Yeah, there we go. There we go. Bear paper. Okay.
Yeah, so are they the same authors for CQL and for this one? Can you
Uh,
it looks
yes.
like
It's all this Averill. I don't know if I pronounced his
yep.
name correctly. But yeah, this is.
Justin and Sergey. Yeah, yeah. It's only Justin is not the same author, but it's still Sergey Levinstein. I think Averill, he's the lead for this whole research.
Mm-hmm,
It
mm-hmm.
feels like.
Makes sense. Yeah, so I was just sort of looking at the paper, didn't have a lot of time to sort of dive into the details, but it almost seems to me that their offline DQN or offline C51 actually works quite well in a lot of the Atari domains. Do you have any intuition as to why? How do they use the offline DQN? Do they just use the dataset as a replay buffer and just train a DQN on that, or?
Yes, they and the data set is a little noisy if I recall correctly. Like there's some stickiness in the actions. So it's not always an optimally derived data set. I think they have a good model first, and they run that model for 10 million frames each environment, or all the environments. I forget exactly how many frames they collect.
Mm-hmm.
But it's not a perfect demonstration because they add the stickiness to it. And then they just replay that data set, and that's what they use for the offline algorithms.
I see, I see. So I was a little bit confused because over here, right, you see the offline DQN and offline C51, they're able to perform quite well, let's say in a breakout environment, reaching about at least 200 reward after the training iterations. However, as you sort of go on in the paper, where I guess this is actually some of the methods that they propose, offline REM or offline QRDQN. However, just by comparing the scores, it seems to be performing much worse. Is it because these ones are trained on bad data sets?
Trying to remember here. So this is on the stochastic version of 5 Atari games with 5 expectation of data. And the previous learning curves, that's from same environments. Yeah, still those 5 environments.
Mm-hmm.
But why are they worse here? I read this for a while ago. I can't remember.
Mm-hmm. Yeah, because I was trying to get the motivations behind it. Because if based on sort of the learning curves above, it seems that if we're just to use offline reinforcement learning right away, it seems to already perform really well. Is it because you want to learn good policies from bad data? That's why you try to develop these new algorithms to learn from data, even those data are sort of mixed.
I think that's one of the goals, is that you don't assume that you have perfectly demonstrated data, unlike what you assume in imitation learning. So that's why they made that stochastic version of that data set.
I see. Yeah, I would say definitely overall very good paper. And another paper that I've been sort of looking at is conservative Q learning, and they have a lot of math going on there. I think they were trying to put a bound on how much the Q function can overestimate. So if you underestimate, you have some nice properties and stuff. But I think somewhere over here they suggested that CQL's performance outperforms previous methods such as Bear. In any case, I thought it was a lot of interesting work in offline reinforcement learning, and with a new data set from D4RL, I think probably in the next 2 to 3 years, there's going to be a lot of research on that.
Definitely seems like a hot area.
Yeah. So out of these papers, could everyone sort of talk about maybe some of their favorite papers, something that they feel really interested in?
I will not call it a favorite paper, but there is the BCQ one, which is titled Off Policy Deep Reinforcement Learning Without Exploration.
Okay.
Which is one of the first that, or is it not the first, that introduces kind of offline reinforcement learning. So implementation-wise, among all those papers we have seen before, I think it's the easiest one. You can check the algorithm at page 5 or 6, I think.
Okay. Oh, there we go.
This is probably the easiest one to implement, since we have already done most of the, like, either DDPG or DQN algorithm. It's just a policy that changes. But the benefits do not seem as good as, for example, Bear or CQL.
I see. I also think this paper looks very similar to the TD3 paper, right? Do they have the same author?
Not that much. Well, it's probably because they build on the same base, namely the DDPG algorithm.
Probably, yeah. So I'm just David Megger. Oh yeah, it's the same author, right? This is the first author is the same. Scott
Yes,
Fujimoto.
it's the same author.
I see. That explains it, because they have I remember quite distinctively that they have this sort of a black dots in their demonstrations, and that is the same in this BCQ paper, where you can see this sort of dots and stuff.
Nice pattern matching.
Yeah, I guess. I'm successful.
As you said before, the Bear also looks quite interesting, but no, not Bear, it's CQL, right? But the theory is quite heavy, so I am not really sure implementation-wise how efficient it's gonna be.
So I think if you look over here, right, skipping a lot of theory sections for a second.
The algorithm.
Yeah, over here you have the practical algorithm. So by looking at this, it does not seem... Oh, I was going to say it does not seem too complicated, but then I see the CQRR, and then I figure it's
That's the part that is supposed to be lower bounded, and the computation of that one goes back to equation. Wait, what was the equation? Maybe equation 2?
Yeah, there's no way for me to find it. Oh, probably over here.
Two or 3 actually, because.
Oh, it's here. It's 3. CQL.
Yeah, it's 3. Yes.
Okay, interesting.
And I believe they have also mentioned some Lagrange-based optimization.
Lagrange-based optimization.
Oh no, it's in the Bear paper. It's in the Bear, another one.
Okay, I see. Yeah, I think they mentioned when I was listening to his lecture. I think I heard Sergi talking about the Lagrangian solutions and
Yes.
yeah, so this is definitely interesting. How about anyone else who maybe have thoughts on which paper they find quite interesting? Okay. I have more questions. So Ali, I remember last time you might have mentioned you have already implemented some of these algorithms. So which are the ones that you have implemented?
So our team has basically experimented with Bear, and then recently D4RL released this D4RL evaluation suite, which has Bear, this other one, AWR, which is the weighted regression one, and a couple others. So we've been just looking at that. For implementation, actually, we've been doing something kind of different, which is we train a simulator on top of the offline data set. So we just train like a supervised learning model that predicts the next state from the current state, and then the selected action, and then use that as the kind of bootstrap simulator to train with regular RL algorithms.
Wait, so you somehow bootstrap it first, and then you use a simulator to train? Is that?
So basically, what you do is say you have like a large collection of examples where you have iterations labeled by iteration at time, a state at time t, action at time t, and then action at time t+1. You can use that to train like a multivariate regression model to predict the next STs from the current ST and current action, and then use that as your simulator. So that's what we've been doing as far as the pitching goes.
I see. Is Bear the only algorithm you guys implemented?
That was the main one that we experimented with, yeah.
I see. I was just wondering if you have a sense of maybe which one is easier to implement, or what are some quirks related to them.
Yeah, I don't have like a great intuition of how much harder each of them are. But I do think like the conservative Q-learning one and the Bear ones are going to be relatively easy because it's just one more constraint that you're adding.
I see. For these algorithms, sort of the new offline reinforcement learning methods, which one do you think is sort of the most interesting? I guess more most interesting, but also potentially a very good target for implementing it for the next monthly development cycle.
I'm guessing the results look really impressive for the optimistic papers, and you've already implemented C51. I don't know how hard it would be to implement REM, but this is just an assembling of existing models. So that might be a good one to try out, I guess.
I see. So maybe just take what we have for C51 and DQN and just take the D4RL dataset and just load the replay buffer and use it to train, something like that.
Yeah, that might be a good initial test.
Okay. This sounds like a very good idea. What about anyone else have any thoughts on maybe what's the one that they really like and consider to be the next algorithm for the next monthly development cycle?
No, I don't have any priorities. I am not knowledgeable on that, so. But I see in many videos where there is so much noise on CQL. Maybe, yeah, but I don't have any priorities towards anything. I'm not sure which is easier or hard.
I see. What about you, Ross? And I remember you mentioned, are you very interested in reproducing the batch constrained Q-learning?
Yes. Well, it's not about interest, but feasibility. Since so far we've only done, what was it, model-free RL algorithm. I thought that by starting with BCQ, we have like a easier way to transition first from model-free to like offline RL, and then from that BCQ, with the basis of BCQ, we can do the other, like either BER or CQL. But since CQL seems to be the most recent and best performing, maybe we could actually just start with that one too. So I don't really know. But let's say that I am balancing between BCQ, BER, and CQL. Yes.
Okay. I see.
Also, I did not read the optimistic of policy. Was it optimistic or pessimistic?
Optimistic.
Yes, that one I did not read yet, so I don't really have any idea about it.
I see.
Especially the distributional part, I am not a big fan lately. Either CQN, not CQN, C51 or QR TQN. I don't know.
Yeah, it definitely, I can definitely see that because the distribution Q-learning distribution perspective, like there's some cool concepts, but I think implementation wise it's very tricky, and I think it's just using, I don't know. Yeah, I get what you're saying. Okay, so I'm just kind of thinking, so maybe for the next monthly development cycle, so I'm hearing sort of a lot of CQL for the moment. Does CQL come with has the source code available?
Yes, there is a official, the author's implementation, I believe. I shared it in a Slack. Oh yeah, that's the one.
Nice. Okay. Have you tried to I don't know, look around the source code? Is it
no.
Okay.
Not that much.
Okay. Well, one thing that is kind of interesting for me, they use dopamine for some of the online baselines, I think.
Do you mean quantile?
Yeah, so for example, if you open DQN agent, it's from the dopamine project.
Oh, I see. So TensorFlow.
Yeah. But if they use something like that, it's not gonna be a huge issue. So it would appear they just run it with the fixed data set, which makes sense. So batch RL.
I think even here they are implemented just on QRDQN.
Sorry?
They implemented CQL on QRDQN. That's what they mentioned in the first paragraph, I think. Here. In the other experiments, you can see CQL is implemented on top of QRDQN.
Right. Yeah. It seems a little strange, right? Yeah. It doesn't seem to have its own file. It just sit in batch RL fixed dataset train, barch RL fixed dataset train. Oh, I see. Maybe this is where the CQL comes in.
I believe they have like a common training file to which they can set what kind of agent they use to train either DQN or QR, DQN, etc.
I see. But if you look at an agent name, right? It's either
Yes.
DQN an agent, fixed replay, rainbow, quantile, multi-head, DQN. Like where is this CQL?
I think I saw CQL training somewhere. CQL trainer. No.
Supposedly this is CQL. So if you look at how you would run it, it says to run CQL, run fixed data set. Oh, I see. So they're somehow using the quantile agent to run it.
Yeah.
So maybe it's something with the pre-processing of the data set that makes it. Maybe they modify the agent somehow, right? Yeah, I don't know what is sort of changed.
I think it's in Quantile agent, yeah. I remember I seeing the push up and pull down somewhere.
Okay. Maybe I can search for keyword. No, it's not very helpful. Yeah, maybe this is something that we can look further into.
Oh man.
Yeah, because I'm not really seeing where CQL specifically.
I think it's in the Batch.rl fixed replay agents.
Yeah, that's where I am right now.
But there is like no explicit kind of agent structure, right? From looking at the paper, the only thing that changes is the computation of the target updates, like for the Q network. But somehow it's does not appear anywhere.
Oh, it's probably over here. In Batch.rl, multi-head, DQN agent. This is where you finally see some definition for the losses. This is probably where the sort of push up and stuff happens, I guess. But it's good that at least we know there is some source code and that we can look further into it.
Some nice spaghetti code.
Well, maybe give it a chance, you know. It's
Yes, of course.
I'm sure it's. Oh, here it is. It's in a quantile agent, and finally in the end you see add the CQL loss.
But why is everything in multi-head, although they say use fixed replay? That's weird.
Yeah, I'm not sure if I understand what fixed sort of multi-head means in this context. But okay.
In the Batch.rl algorithm, which is in RL-Kit. Okay. So in CQL, it should go up a directory. I don't know. Sorry. I'm looking at a different edition of CQL.
Oh, okay.
Which is in the D4RL repo.
Okay. So another thing that I think might be interesting for our discussion is to note that some of the experiments and data sets are already included sort of in this newer version, this new algorithm CQL. Like some of the data sets used in the optimistic perspective paper, it seems that they're also using the same data set in the CQL paper. So I remember Yeah, they were doing some comparison with the optimistic perspective paper, and they kind of show that CQL performs better, supposedly. This is also another reason why it's if you guys look at the charts, right? I see. So offline RAM goes to about 100. Okay, that's reasonable. Yeah, I see. Yeah, overall, yeah, I would say probably start with CQL, but maybe also keep in mind of the other algorithms. See maybe if it's easy to examine other algorithms as well. Maybe once we maybe maybe we start with CQL, but then maybe as we read the paper, we find more things. It is okay to change sort of the monthly development cycle to other algorithms as well. I don't know. What do you guys think?
It's probably better that way. Let's use CQL as default, since it's the better performing.
Okay.
And we'll see the rest, I guess.
Okay. Yeah, I think that sounds good. Let's plan on that then. Then maybe for next week, let's try to read the CQL paper and discuss it. So I guess for this monthly development cycle, we'll sort of have 2 literature week. This will be the first literature week, and the second literature week will more focus on the conservative Q-learning algorithm. But at the same time, feel free to read the other algorithm. And then starting next week, we'll try some implementations out. How does that sound to everyone?
Yeah, that's fine.
Okay. Ali posted something.
So I was getting confused as to where I found that from. But it looks like they just added a fork of RLKit in the D4L directory.
Yeah.
And in there, there's a new algorithm called Fragile algorithm, a new class, and then it looks like in here they define the policy update and how they add to the replay buffer from the sample.
Mm-hmm. I see. Wow.
So
So
the actual.
what is RL-Kit anyway? It's my first
It
time
looks like
hearing
another
that.
framework. Probably not as good as CleanRL, but
I wouldn't say so. Just a lot of options and different trade-offs. So maybe this one is something that they're developing more internally. I don't know. We'll have to see. Okay, I think that sounds good. Does anyone have any thoughts on maybe something that they want to look at, or any questions?
has anyone installed D4L and played with some of the environments they have in their datasets?
I have not for now, but I would be happy to next week.
I haven't. So it should be installed. It should be installed in a Linux OS, or it can go in Windows 10 too.
Sorry, are you asking if it's only Ubuntu or?
Yeah, can we install it in Windows or it will work only in Ubuntu? Yeah.
Oh, I don't know.
Okay.
I haven't installed it on Windows before.
Linux is probably the way
Okay.
to go.
Okay. I'll stick with it.
But since it's mostly data sets, is there even any need to have like simulators running?
No, which is why I don't quite understand why they have Majoko as dependency in there. So
Probably for the evaluation, I guess.
Yeah.
yeah, on Mac it's not possible right now to install Majoko Pi on Python 3.8.
Oh,
So
really?
I had to go. Yeah, I had a virtual environment for CleanRL that was 3.8.5, but I had to create a new one, and now it's okay.
I see.
The RL Unplugged paper, they put their data set in a Google Cloud, a storage bucket.
Really?
I didn't think that's much bigger because it's Atari data,
Mm-hmm.
so lots of images.
Oh, I see. Oh, I wonder how big are these? Oh, I see. Yeah, 1.2 gigs and stuff for 500 of them. Wow, quite a bit of them.
That's what she said.
Wow, never realized that part of you, huh, Rosalind? Oh my god, that's the best.
600 gigabytes
Wow.
just for one environment.
Yeah.
Yeah.
And they have 57 in Atari,
That's crazy.
so it's like 3 terabytes plus.
Okay, I
Yeah.
guess I would try downloading this locally.
Yeah, it's crazy.
It's 40 terabytes.
So for D4RL, it looks like they have added this new get dataset method to the environment Joko class. And then from there, you get dataset, and then you can append that to your replay buffer.
Mm-hmm. Oh, I see. Yeah, you can use a GS util to sort of download everything from the Google Cloud bucket. But wow, that is crazy number of data there. All right. That sounds good. Does anyone have any thoughts? Additional thoughts or comments?
So this D4RL, this won't work with this pipelet. Pipelet, this needs Majoko for sure.
Probably, but also I think you probably wouldn't have to install Mujiko or Pipelet. You probably can just run regular. Just run with Atari first, and that way you don't have to worry about Mujiko license and stuff.
Okay, fine. Got it.
Yeah, they also have this quite interesting domain, right? In D4RL, they have this Carla environment, which is sort of a driving in real world scenarios. So that might be also quite interesting as well. Yeah, so it's this Carla.
This Carla uses Unreal Engine 4, and just to set it up, man.
It's hard. Oh, they especially. So this is how you know it's not good, right? There is some additional setup required for Carla.
Depending on the version, it's not that bad. I have gotten version 0.9.6 to run, but
Okay.
there seems to be 9.8, and it's like probably a different word. So I don't know.
Have you
Also, it uses quite a lot of processing just to run the simulator.
for sure? Have you been able to run Carla as a reinforcement learning environment? Have you done some experiments
Yes.
with it?
Yes.
Do you did you at least have the car learn anything? I don't know, some very
Oh yes, it learned to crash very well.
fantastic. Fantastic. That is what I'm talking about.
I think since I basically had to build a custom wrapper because there's no real objective. You just get the simulator, so you have to build the scenario you want the agent to train in. I think
Okay.
at that time at least. So I guess I did not design a good enough reward function, so the car ended up like running in circles.
Okay. Okay. Well, that's actually quite interesting because I have something like that to show. But when I was trying the car racing, yeah, there is one instance where the car is doing circle as well. But definitely the Carla version is more brutal, I guess.
Yes. Also,
Yeah, never
there's
mind.
only like a pixel-based observation, so
Right. Yeah, that is a huge
that's
difference.
another challenge.
Although I think in Carla you can configure to use some more high level, some lower level observation, right?
I guess it's possible,
Like
but
you,
you'll have to design the observation.
no, like they provide this out of the box, right? Or do they not?
You have to write the function that will collect, for example, the XYZ position. The API is here, but to interface with the reinforcement learning algorithm, I did not find much
Okay.
like direct thing like let's say, for example, step. What comes out of the ops, you have to build the format yourself.
I see. Okay.
But it's not impossible.
Right. Yeah, that's interesting. Yeah, I saw there's some work in sort of autonomous driving as well. And I don't know, that might be like a new directions in the future, instead of the current approach that is you train sort of you use these lower level representations such as object segmentation and then add a lot of components, but maybe in the future everything can just be done from end to end.
Hopefully.
Yeah, I think that'll be interesting. It'll be hard to interpret, that's for sure. No, that's probably bad. All right. In any case,
So CQL it is.
yeah, CQL it is, and let's give it a try and see how it goes. All right. Maybe does anyone have any last comments?
The environments to be used are Atari ones.
I don't know. Whichever you prefer, you know.
Well, beside my personal preference, I guess I don't think I have any, but computation-wise, I would say that Mujoko-based environments would probably be faster.
Yeah. Although those are all offline observations, and once you have a GPU, it shouldn't make much of a difference.
Indeed. But also, there's the problem of mutual code license.
Yeah. So
Maybe add.
yeah, so I don't know.
Okay, let's burn that bridge when we get there.
Exactly, that's the spirit.
Yeah.
Okay, all right, sounds good. Does anyone have any last comments? We can also try to wrap up a little early today.
No, I don't have any comments right now. We'll start with CQL and let's see how it goes.
Yeah, sounds good to me. All right, thanks everyone for coming, and have a good weekend, guys. And let's talk next week.
Thank you everyone. You get to Cantonese again. Bye.
Yep,
Yes.
sounds
Goodbye.
good. All right, bye.
Bye.